Today's video is on freshwater, rivers, and streams. Running water is the most important geologic agent in eroding, transporting, and depositing sediment. Nearly every landscape on Earth shows the results of stream erosion or deposition. A stream is a body of running water that runs downhill under the influence of gravity, and it's confined to what we call a channel. The headwaters are the upper part of the stream near the source, which is usually up in the mountains. The mouth is at the other end, where the stream enters the sea, the lake, or a larger stream. And the channel is the long, narrow depression eroded by a stream into the rock or the sediment. So it's the actual bedrock underneath the stream. And we call the sides of the channel the stream banks, and the bottom of the channel the stream bed. The floodplain is the flat valley floor composed of the sediment that gets deposited by the stream in various times of its life. A river system acts somewhat like a system of downpipes and gutters that you might find on your house. It allows the movement of rainwater into the oceans, just like your gutters collect water and move them through a series of downpipes into a downspout. And just like your gutters, the movement of water in a river system is fueled by gravity. A typical river drainage basin is pictured here, and this is what we think of as the catchment area for all the rain that falls within that watershed. And a watershed is the space between two boundaries, two higher areas of land. And so if we look here, we see some higher land surrounding this drainage basin here. So everything inside of there is considered the watershed. The source is the place where the river begins, and typically a river system has numerous sources, often underground springs and also snowmelt from mountains. A confluence is an area like right here where you have two rivers meeting, often a smaller river and a larger river. And these smaller streams are called tributary streams, and they're smaller rivers that flow into a larger one. Here's another picture of a watershed, and you are able to see the entire drainage basin there with some of the main streams and also some smaller tributaries. All the rain falling within a drainage basin ends up in the river system. So how does it get there? Well, one way is through channel flow, which is when raindrops fall directly into the river or the stream. But most of the space, and if you look at most of the area in a drainage basin, if we go back here and look at it, most of that is taken up by land and not water itself. So most of the rain falling in an area actually falls onto land first. So most of it is surface runoff. And this is when water runs downhill over the ground towards a river or a stream. We also have underground water flow. This is when raindrops infiltrate the soil and the rock, and then the water moves underground towards the stream or the river. So the question is, which route to the river is quicker, surface runoff or groundwater flow? And the answer is that rain traveling as surface runoff gets to rivers and streams much more quickly, reaching it without much delay within a pretty short time span. Water that infiltrates and travels underground travels much more slowly, finally reaching a river or stream bit by bit over a much longer period of time. So which situation is the river more likely to be able to cope with without flooding? Well, surface runoff has a shorter lag time, but has a higher river peak discharge. So it has actually a more likelihood of flooding. Let's talk about which conditions make surface runoff more likely. When you have urbanization within the drainage basin, which is when large areas are concreted over, making the surface non-permeable, which means that water cannot penetrate the surface. So the water simply runs over the concrete in the area. Often, we have storm drains built into our roads, of course, but these carry water pretty quickly to a river, so it makes the lag time even shorter. Also, areas with very few trees make surface runoff more likely. And this is because tree roots break up the soil and provide nice little gaps for the water to infiltrate down into the ground. And then the trees take up and store water from underground. So if you don't have very many trees in an area, then you're more likely to have a lot of surface runoff. Also, very steep slopes increase surface runoff. Water is able to flow downhill very, very quickly with a lot less time for infiltration to occur. If you already have a very high water table, so if you've had a lot of rain in the recent past, this is going to make surface runoff more likely. Very heavy rainfall will make surface runoff more likely, and also when you have non-permeable rock within a drainage basin. So if the water can't infiltrate the ground, it's going to run off the surface. So let's take a look at some drainage basin. Now, the definition for a drainage basin is the total area drained by a stream and its tributaries. And a tributary is a small stream flowing into a larger one. A divide is the ridge or high ground that divides one drainage basin from another. And the continental divide that we see here in red separates the streams that flow into the Pacific from those that flow into the Atlantic and the Gulf of Mexico. And here's a closer picture of it, so we can see the Mississippi River drainage basin here and all of the smaller tributaries that drain into it. And we see the continental divide here that separates all of the streams over here that run into the Pacific with all of the streams over here that run into the Atlantic and the Gulf of Mexico. This is the Big Sandy, which is a nice meandering stream. Streams that meander flow faster along the outside of the bends and more slowly along the inside of bends. And this is very important because this controls their formation. And they often deposit point bars on the insides of those meanders, which change the meanders themselves. Meander cutoffs might form when a new shorter channel is cut through the narrow neck of a meander. So what we see down here below, here we see a nice meander, if you can see my pointer here, a little meander there. And what ends up happening is that the meander, the neck of it gets narrower and narrower, and then eventually that gets cut off and straightened, and then what we have forming here is called an oxbow lake. And we see the same thing up here, and you can see that the brown river here is the river that's flowing, and so it's carrying sediment, which is why it looks brown. And then here, the water that looks clearer is because that's an actual lake, so we don't have the moving water there, so all the sediment is settled down towards the bottom. And up here we can see some nice pictures of a meander and how it gets more and more curvy, and that's because, remember, the outside of the bend moves more slowly, the outside of the bend moves more quickly, and the inside moves more slowly. So on the inside we get these little deposits, and on the outside we get erosion, and so that meander gets bigger and bigger and bigger the longer the river's there. So here we have the deposition of some sandbars and the formation of crossbedding, and here's an oxbow lake forming there. You can see where it's been cut off there. Now let's talk a little more about stream erosion and deposition, because those go together. And this is controlled by two factors in a stream: the velocity, or the speed, and also the discharge, or how much water it's moving. Stream velocity is controlled, or the stream speed is controlled by the gradient, the slope of the stream, also the shape of the channel, and how rough the bottom of the channel is. And the maximum velocity is near the center of the channel. So if we look in this picture up here, these are different cross sections of a channel, and those darker areas are showing us where the maximum velocity is at. Higher stream velocities promote more erosion and transport of heavier, coarser sediments. Floods involve increased velocity and discharge, which is, remember, discharge is the volume of water passing a particular point in the stream over time. The stream gradient is the downhill slope of the stream bed, and this is typically measured in feet per mile, and it usually decreases the further downstream that you are. Channel shape and roughness is both affect stream velocity due to drag, and narrower, deeper channels allow for faster flow. Smoother channels allow for faster flow, and wider, shallower channels decrease the speed of the flow. Stream discharge is how much water, remember, how much water is flowing past a given point in a certain unit of time. A stream valley develops over time, and it develops through a process called downcutting, which is the deepening of a valley by erosion of the stream bed. And V-shaped valleys typically form from downcutting combined with lots of erosion. Streams cannot erode below what's called their base level, which we can see right here for these different streams. They have different base levels. They cannot erode below that. A base level can often be sea level or maybe the bottom of a closed basin. The downcutting rate can be pretty rapid. If a stream is pretty high above the base level, then it can downcut and erode away pretty quickly. Flooding occurs when water levels rise overtop the banks of a river. This is a natural process that occurs on all rivers during different points in their lives. We describe these by recurrence intervals. A 100-year flood then would be, on average, the size of the largest flood within a 100-year period of time. Floods can cause great damage in heavily populated areas. They have a high velocity and a large volume of water, which can cause erosion from the flooding. When the waters start to slow, then we have deposits of the material that they've been carrying, and these get deposited into the floodplain. When we have a lot of paved areas and storm sewers, we know that these increase runoff by inhibiting infiltration, and this can cause a rapid delivery of water to streams and increases their discharge and makes floods happen more quickly. Flash floods are sudden, localized, small-scale floods of a very large volume, but they last for a very short period of time, and these are typically triggered by heavy rainstorms. There are a few different ways that we try to cope with and control flooding. One are dams, and these are designed to trap floodwaters in reservoirs that are upstream and release it gradually over time. Artificial levees, which are designed to increase the capacity of a river channel, and these tend to work well, but until a stream overtops the raised levees, leading to very, very extremely rapid flooding and erosion. The most effective type of flood control is very wise land use planning. This includes the prevention of building within that 100-year floodplains. So instead of trying to control the river itself, we just don't build near it, and we try to make sure that we don't develop any land within that 100-year floodplain. This is a picture of the Mississippi River, and at the top here we see a before picture, and then a flood happened in 1993, and so we can see the after picture there. And if you just take a look at the size of the channel there, you can see how much it has changed. And this is a river that there was a levee here, and so you see the normal river flow here, and there was a break in that levee, and you can see that it's a very, very rapid discharge of water. And here is another river that has flooded, and so you can see, when you develop right near a floodplain within that 100-year interval, there's a pretty good chance that it's going to be flooded at some point in its history. So that's it today for Rivers and Streams. Our next video will be on ponds and lakes.